Welcome back, Focus Learners. I am absolutely thrilled you're here today because we are going to unlock some incredibly practical, everyday skills that double as essential exam strategies. We're diving directly into the core concepts from Chapter 16 of the Cambridge IGCSE syllabus, all about money. And look, I know what you might be thinking. Math can sometimes feel, well, a bit abstract, like when am I ever going to use this, right? But not today. Today, we are translating textbook equations into real-world financial mastery, which is exactly what Cambridge examiners want to see. Okay, let's jump right in. We've all been there, right? You're standing in the supermarket aisle, looking at a massive family-sized box of something, and right next to it is the regular-sized box. It's so incredibly easy to assume that the biggest size automatically gives you the absolute best value for your money. It's practically a shopping reflex at this point. But is that actually a mathematical certainty? Well, as we're about to see, the answer might totally surprise you. Our source material today is Chapter 16 of our text, which specifically targets calculating value for money and converting between currencies. We're going to extract the exact math skills, specifically unit pricing and exchange rate logic, that empower you to make the right financial conclusions every single time. All right, here is our roadmap for today. We'll cover 1. The bulk buying myth. 2. 3 value calculation methods. 3. Spotting the better deal. 4. The currency conversion code. 5. Multiplying versus dividing. And finally, 6. Essential money master keys. But before we conquer that first topic, make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get into it. Section 1. The bulk buying myth. Let's put that bulk buying theory to the ultimate test, using a highly relatable scenario directly from the text. Let's set the stage with example 16.1. We have 2 packets of Wheato Flake cereal. The large packet weighs 1.5 kilograms and will set you back $4.99. The smaller packet weighs 500 grams and costs $1.70. Now, relying on gut instinct isn't enough here, especially on an exam. We need cold, hard mathematical proof to determine which one actually offers the better value. Section 2. 3 value calculation methods. The textbook presents us with a really handy toolkit here. There isn't just one correct way to figure this out. This brilliantly illustrates our first 2 options. Method 1 approaches the problem by finding the cost per unit of weight, specifically the price for each kilogram. Basically, you're asking, how many dollars am I paying per kilo? Method 2 comes at it from the exact opposite angle. It looks for the weight per unit of cost, so finding out exactly how many grams of cereal you get for every single cent you spend. Both work perfectly. Let's break down Method 1 step by step. For the larger 1.5 kilogram packet, we take the price, $4.99, and divide it by the weight, 1.5. This gives us roughly $3.326 per kilogram. For the smaller packet, we have to convert the 500 grams to 0.5 kilograms first. Gotta make sure our units match. Dividing $1.70 by 0.5 gives us exactly $3.4 per kilogram. Comparing the two, 3.326 is slightly less than 340, so the crucial takeaway is that the larger packet costs slightly less per kilogram, making it the better value. But wait, before you reach for your calculator to manage those decimals, the text reveals what it calls an obvious easier method, and this is a real game changer for saving time. Look at the weights, 1.5 kilos versus 500 grams. The larger packet is exactly 3 times the weight of the smaller one. So skip the division entirely. Just scale up the small packet. If you buy 3 small packets to equal 1.5 kilos, you multiply $1.70 by 3, which equals $5.10. Suddenly, the comparison is incredibly simple. $4.99 for the large box is definitely less than the $5.10 it would cost to build the same amount with small boxes. Beautifully efficient, right? Section 3. Spotting the better deal. We've mastered cereal, but how do we handle complex promotional offers where the rules seem to change based on how much you buy? Check out example 16.2. We're shopping for t-shirts, and we have 2 rival stores. Mega T has a classic promotion. Buy 2 t-shirts at $7.99 each, and you get a third one entirely free. T-World, on the other hand, drops the price to a flat $5.50 per shirt, but only if you buy 2 or more. The question isn't just which is better, it's which is better depending on exactly how many shirts you need. And hey, speaking of spotting a great deal, stop scrolling for a second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped so many students level up, so join the community right now. All right, let's run the numbers on these shirts. Let's say you want exactly 3 t-shirts. At Megatee, you're paying for 2 shirts to get that third one free. So 2 times $7.99 equals $15.98. Easy. At T-World, you're buying 3 shirts at the discounted rate of $5.50 each. 3 times $5.50 is $16.50. In this specific scenario, Megatee's buy 2, get 1 free offer is the clear winner, saving you a few cents. But here is where the text throws a brilliant curveball, and examiners love doing this. What if you want 4 t-shirts instead of 3? At Megatee, you already paid $15.98 for the first 3, but that 4th shirt, yeah, that's going to cost you the full $7.99 price tag. Your total jumps to $23.97. Meanwhile, over at T-World, the flat discount still applies to every shirt. 4 shirts multiplied by $5.50 equals exactly $22. By simply changing the quantity we needed from 3 to 4, the math completely flipped, and T-World is now the cheaper option. You see? You must always run the numbers for your specific scenario. Section 4. The currency conversion code. If you've ever traveled internationally, you know the headache of exchange rates. Let's decode that process right now. First, let's establish our foundation. What exactly is a currency exchange rate? As the text defines it, it's simply a number that tells you what one unit of a currency equals in another. For example, if the exchange rate is $1 equals 0.88 euros, it literally means every single US dollar in your pocket is worth 0.88 euros. And this brings us to what might be the most important sentence in the entire chapter. The textbook states, when you are given an exchange rate, the only decision is whether to multiply or divide by that rate. That's it. It demystifies the whole thing. You don't need complex, multi-step formulas here. You just need to make one binary choice. Am I going to multiply or am I going to divide? Section 5, multiplying versus dividing. Let's look at exactly how to decide whether to hit the multiplication or division key on your calculator. We have 2 people in example 16.3 facing this dilemma, dealing with that same $1 equals 0.88 exchange rate. First, we have Sam. Sam has $135 and wants euros. Because he knows the exact euro value of a single dollar, he simply multiplies. 135 times 0.88 equals $118.80. Now look at Francoise on the right. She has 340 euros and wants dollars. She doesn't have a direct 1 euro equals X dollars rate given to her. She needs to find out how many chunks of 0.88 fit into her 340. So she divides. 340 divided by 0.88 gives her $386.36. Now, if you're ever panicking during an exam, wondering if you did it backward, the textbook offers this absolutely fantastic sanity check. Look at the core rate. $1 equals 0.88 euros. Because 1 is bigger than 0.88, the number of dollars in your calculation must always be greater than the number of euros. Francoise divided and got $386 for her 340 euros. The dollar number is bigger, so logic tells us she absolutely chose the correct mathematical operation. And guys, please listen up because here is a critical pro tip from the text's notes section regarding how you format your answers. This is where so many marks are lost. When Sam multiplied 135 by 0.88, his calculator probably just spat out 118.8. But we are dealing with currency. The text strictly mandates that you always use 2 decimal places for money questions, representing the smaller unit, like cents, so you must write it as $118.80. It's a small detail, but it's exactly what Cambridge examiners are looking for to show true mathematical precision. Section 6, Essential Money Master Keys. We've covered a lot of ground today, from supermarket cereal aisles to international currency exchanges. Let's synthesize all of this. Here is your ultimate cheat sheet to lock in today's learning. First, when comparing value, calculate either the price for each unit or the amount you get for each unit of money. And hey, remember that scaling trick if the weights are easily comparable? Second, for currencies, your only job is deciding whether to multiply or divide by the provided exchange rate. And finally, always perform that logical sanity check to verify your operations. If $1 is less than £1, your dollar total should always be higher than your pound total. So, I leave you with this. The next time you are evaluating a promotion or sitting in that exam hall staring at your 0580 paper, which of these structured mathematical methods will you pull from your toolkit to guarantee you're getting the right answer? Mathematics isn't just about passing tests, it's about navigating the real world with total confidence. Keep practicing these steps, and you'll be a master of money math in no time. Students who implement these strategies see massive improvements, but only if they practice consistently. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Thanks for joining me on this explainer, and I'll see you next time.